1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. With just these 10 symbols, we can write any rational number imaginable. But why these particular symbols? Why 10 of them? And why do we arrange them the way we do? Numbers have been a fact of life throughout recorded history. Early humans likely counted animals in a flock or members in a tribe using body parts or tally marks. But as the complexity of life increased, along with the number of things to count, these methods were no longer sufficient. So, as they developed, different civilizations came up with ways of recording higher numbers. Many of these systems, like Greek, Hebrew, and Egyptian numerals, were just extensions of tally marks, with new symbols added to represent larger magnitudes of value. Each symbol was repeated as many times as necessary, and all were added together. Roman numerals added another twist. If a numeral appeared before one with a higher value, it would be subtracted rather than added. But even with this innovation, it was still a cumbersome method for writing large numbers. The way to a more useful and elegant system lay in something called positional notation. Previous number systems needed to draw many symbols repeatedly and invent a new symbol for each larger magnitude. But a positional system could reuse the same symbols, assigning them different values based on their position in the sequence. Several civilizations developed positional notation independently, including the Babylonians, the ancient Chinese, and the Aztecs. By the 8th century, Indian mathematicians had perfected such a system, and over the next several centuries, Arab merchants, scholars, and conquerors began to spread it into Europe. This was a decimal, or base 10 system, which could represent any number using only 10 unique glyphs. The positions of these symbols indicate different powers of 10, starting on the right and increasing as we move left. For example, the number 316 reads as 6 times 10 to the 0th power, plus 1 times 10 to the 1st power, plus 3 times 10 to the 2nd power. A key breakthrough of this system, which was also independently developed by the Mayans, was the number 0. Older positional notation systems that lacked this symbol would leave a blank in its place, making it hard to distinguish between 63 and 603, or 12 and 120. The understanding of 0 as both a value and a placeholder made for reliable and consistent notation. Of course, it's possible to use any 10 symbols to represent the numerals 0 through 9. For a long time, the glyphs varied regionally. Most scholars agree that our current digits evolved from those used in the North African Maghreb region of the Arab Empire. And by the 15th century, what we now know as the Hindu-Arabic numeral system had replaced Roman numerals in everyday life to become the most commonly used number system in the world. So why did the Hindu-Arabic system, along with so many others, use base 10? The most likely answer is the simplest. That also explains why the Aztecs used a base 20, or vigesimal system. But other bases are possible too. Babylonian numerals were sexagesimal, or base 60, and many people think that a base 12, or duodecimal system would be a good idea. Like 60, 12 is a highly composite number that can be divided by 2, 3, 4, and 6, making it much better for representing common fractions. In fact, both systems appear in our everyday lives, from how we measure degrees and time to common measurements like a dozen or a gross. And of course, the base 2, or binary system, is used in all of our digital devices, though programmers also use base 8 and base 16 for more compact notation. So the next time you use a large number, think of the massive quantity captured in just these few symbols, and see if you can come up with a different way to represent it.